All right, so clearly I underestimated how much time would be needed for this video lesson. So this is part 2 of a continuation with the problem 7.9 from the course textbook. All right, for step 4, we're going to be looking at the percent air content requirements. To do that, we're going to look at table 6 in the book, chapter 7. So if we look at this table, you can see that it's called the approximate target percent air content requirements for different nominal maximum sizes of aggregate. So we need to know the maximum aggregate size, which is 2 inches. And it gives you two options for either non-air entrained or air entrained, and of course we're using air entrainer. But then it gives you an option of mild exposure, moderate exposure, or severe exposure. And in our case, because it's a cold climate and it's pavement, it's going to be exposed to de-icing type solutions. It's going to be under severe exposure. So we go to the table and find the value. We see that, let's see, 2 inches, severe exposure. We see that the approximate target is going to be 5.0%. But if you notice at the bottom, it says that air content in job specifications should be specified to be delivered within -1 to +2% of the target value for moderate and severe exposures. So in our case, it's going to be between 4% and 7%. In using this, we're going to design on with a 6% air content. All right, so step 5 is going to be looking at the workability of the concrete once it's mixed. And of course, when you're looking at workability, you look at the slump tests. So what we're going to do is look at table 7 in chapter 7, and that's going to give us a maximum and minimum slump for different types of construction of concrete. In our case, we're doing a pavement slab, so that would be under pavements and slabs, and that gives us a maximum slump of 3 inches and a minimum slope of 1 inch. And for this case, we're just going to split it right down the middle and use 2 inches. So for step 6, we're going to look at the water content. To do this, we're going to look at table 8 in the book in chapter 7. And you can see there's 3 things that we need. We need the slump in inches, and in our case, that's 2 inches. We're going to be using air entrained concrete, and the nominal maximum aggregate size is 2 inches. So if we simply follow the table, we'll get the amount of water needed in pounds per cubic yard. So if we follow the table, we see that what is needed is 240 pounds per cubic yard. Now this is assuming a saturated surface dry condition, but we'll account for that in step 10 later. All right, in step 7, we're going to look at the cement content requirements. And to do that, we have the weight of water that we calculated earlier, as well as the water to cement ratio we calculated in step 2, I think that was. It's a simple equation. All we do is we take the weight of the cement is going to be equal to weight of the water divided by the water cement ratio. And in this case, it's going to be 240 pounds per yard cubed divided by 0.45. And that's going to be equal to 533 pounds per cubic yard. However, if we go to page 264 under the heading Cement Materials Content Requirements, it says PCA recommends a minimum cement content of 564 pounds per cubic yard for concrete exposed to severe freeze-thaw, de-icers, and sulfate exposures. And in our case, we are exposed to that. And because that's a higher value, we're going to use that. So the cement content for this mix is going to be 564 pounds per cubic yard. It looks at admixtures. For that, we need the cement content we just calculated, which was 564 pounds per cubic yard. We also need the air content we calculated at 6%. And we were given an air entrainer specification, and the air entrainer is the only admixture in this mix. But this specification we were given is 0.15 fluid ounces per percent air per 100 pounds. And that's a pretty straightforward calculation. So our admixture is going to equal 0.15 fluid ounces per percent air per 100 pounds times 6% air times 564 pounds per cubic yard. And this ultimately equals 5.1 fluid ounces per cubic yard. Pretty straightforward.